Okay, moving on to EG number 2. We have this function, integrate 1 over 1 minus 3x plus 1 over 1 minus 3x all squared, subtract 1 over cos squared x over 3. Okay, same as before, treat them separately. So I'm integrating 1 over 1 minus 3x with respect to x. I'm going to integrate 1 over 1 minus 3x all squared with respect to x, subtract integrating 1 over cos squared x over 3 dx. Now, some of these I can't integrate yet, even using good guessing. The only one I can integrate with a good guess so far is this one. All of the others need to be rewritten as something else. So think about another way you could write this. It would be index form, 1 minus 3x to the power of minus 2 dx. So something to the power of negative 2. Subtract 1 over cos squared. Well, 1 over cos is sec, so 1 over cos squared is sec squared. So subtract integral of sec squared x over 3 dx. Okay, finally we can get started. So think about what good guesses would be for all three of these. The first one, best guess would be ln 1 minus 3x. See how bad the guess is. dy by dx is 1 over 1 minus 3x. But you've got to remember the chain rule, times by this thing differentiated, which is minus 3. Okay, so minus 3 over 1 minus 3x. However, we wanted a 1, so we're out by a factor of negative 3. So if I call this entire integral I would be equal to my guess, but minus a third of it. Okay. Second one. 1 minus 3x to the power of minus 2. Now, if I show you that page in the textbook, which one of these helps you with this one? Well, it's the first ever rule of integration you've ever were taught. Something to the power of n or something to the power of negative 2, you add 1 to the power. So let's add 1 to the power and guess that. Y is equal to 1 minus 3x to the power of negative 1. dy by dx. Okay, something to the power of negative 1 using the chain rule. Bring the power down, subtract 1 from the power. But remember to times by the bracket differentiated. And that differentiates to negative 3. Which is equal to positive 3, 1 minus 3x to the negative 2. We wanted a 1 at the top. We've got a 3. So we're out by a factor of 3. So plus 1/3 of my guess, 1 minus 3x to the negative 1. Last one. Try a guess. Y is equal to, now sec squared, similar to the previous one, i.e. number 1, is linked to tan. So tan x over 3. See how bad the guess is. dy by dx is equal to tan goes to sec squared. We got times by that bracket differentiated. Now what does x over 3 differentiate to? Well, if you think of x over 3 as a third x, it'd be times in by a third. And that is 1/3 sec squared x over 3. We didn't want 1/3, we wanted one of them. So we have to subtract 3 times our guess. Remember the plus c. You only need one plus c, by the way, because the plus c's of all of these would just combine as a single plus c. So your final answer would be all of that. Okay, one more example. E.g. number 3. I think there's one more. Yeah, one more. This is called definite integration, when you've got limits. And we have to find one of those limits. So they've given us the answer, and we have to work backwards. So, if we just want to integrate this function, what would our guess have to be? 3x minus 5 to the power of 4. Okay, this is something to the power of 4. And for integration, you would normally add 1 to the power. So let's guess y is equal to 3x minus 5 to the power of 5. Differentiate to see how bad the guess was. Bring the power down. Subtract 1 from the power. But the chain rule says you have to multiply by that thing differentiated. So multiply by 3, which is equal to 15, 3x minus 5 to the power of 4. 15 wrote by a factor of 15. So this thing integrates to 1/15 of my guess. Don't need a plus c for this because they cancel out. I'll write it in a different colour. It's just an option, but you don't need it. Between the limits of x is 1 and x is equal to little a. And that answer needs to be 11 over 5. Now, what do you do with the limits? You substitute them in. So you got a 15th of, replace all of the x's with a, 3a subtract 5 to the power of 5. Subtract, might put these in big brackets as well, 1/15, 3 brackets 1 subtract 5 to the power of 5, there we go. That's equal to 11/5. Now, be smart here, don't do something like a single mathematician would do. You want to not expand these brackets. You don't want to use binomial expansion at all. Go around in circles. So leave that as 1/15, 3a subtract 5 to the power of 5. Simplify this on your calculator. So we are subtracting 1/15 brackets 3 1s subtract 5 to the power of 5, which is subtracting minus 32 over 15, and that's equal to 11 over 5. Simplify. Subtracting a negative, same as addition. And now you want to make a the subject. But again, you can't do a single mass thing, which is expand the brackets. So the only thing you can do, well, there's two things you could do. I'm going to subtract 32 over 15 from both sides. So 11 over 5 subtract 32 over 5 is minus 21 over 5. Hang on. That is 15s instead. 15s. 1 over 15. Then get rid of the denominators. 3a minus 5 to the power of 5 is equal to 1. Without expanding the brackets, you'd have to do the fifth root. So 3a minus 5 is equal to the fifth root of 1, which is 1. Add 5, divide by 3, a would have to be 2. And you can use your calculator to check this as well. So a is 2. Go back up to the original. Use the integration button on your calculator if you've got the fancy calculator. Integrate 3x subtract 5 to the power of 4, the original thing, between 1 and I'm claiming 2. My calculator will take some time to think about it, but hopefully it will agree with 11 over 5, and it does. So I know I've done that right. Now, what I want you guys to do today is exercise 11b, which we've started on page 297 and 298. You're going to try question 2, if you haven't done so already. You're going to try question 4, and you're going to try question 6. 2, 4, and 6. If you've got any questions about any of those, post a question in the Teams chat.